Welcome students to the IIT PAL problem solving session on mathematics. Our topic is probability and this is lecture number 5. If you remember, we are working on conditional probability and in particular we are working on the following problem, that there is a bag containing 12 red balls and 8 green balls. 3 balls are drawn in succession without replacement. We know that probability first ball is red this event we are calling as R1 and that is going to be 12 upon 20 is equal to 3 upon 5 and probability the first ball drawn is green, that probability is going to be 8 upon 20 is equal to 2 upon 5. We have calculated some conditional probabilities. Say probability the second ball drawn is green given that first ball drawn is red, and we know that this probability is going to be 8 upon 19. This we have already seen. My question is, what is the unconditional probability that the second ball drawn is green? That is the question. That is, we are looking at probability of G2. Now, the event G2 is actually union of two events. First ball is red and second ball is green, union. First ball is green and the second ball is green. Therefore, probability of G2 is equal to probability R1 G2 union G1 G2. So, let us compute this. Our initial configuration is 12 red balls and 8 green balls. Event R1, first ball drawn is red, that brings us to 11,8, and if the first ball drawn is green, then we come at 12,7. Now, if I have G2 here, that the second ball drawn is green, then the configuration is going to be 11,7. 7. And from here, if the second ball drawn is green, then our configuration is going to be 12, 6. Therefore, probability of G2 is equal to probability of R1 intersected with G2 plus probability G1 intersected with G2. We know that this we can write as probability G2 given R1 multiplied by probability of R1 plus probability of G2 given G1, this multiplied by probability of G1 is equal to probability of G2 given R1, that is this probability, which is going to be 8 upon 19 multiplied by probability of R1, which is going to be 12 upon 20, which is nothing but 3 upon 5 plus probability G2 given G1, that is we are here, therefore, that probability is going to be 7 upon 19 multiplied by probability of G1, which is going to be 8 upon 20, which is 2 upon 5 is equal to 24 plus 14 upon 19 into 5 is equal to 38 upon 19 into 5 is equal to 2 upon 5. So, that is a bit new result. We knew that the unconditional probability of the first ball drawn is green is same as 2 by 5, because that was 8 upon 20 is equal to 2 by 5, and now we get the unconditional probability of drawing the second ball to be green is also same as 2 by 5. I want you to verify that the unconditional probability of R2, that is the second ball drawn, is red, and perhaps you can guess that answer is going to be 3 by 5. I want you to verify that. Now, let us go one more step. What is the unconditional probability that the third ball drawn is red? So, let us start. The third ball can be red is union of 4 disjoint events. What are they? First one is red, second one is red, and third one is red. Union, first one is red, second one is green, and then third one is red. Union, first one is green, second one is red, and third one is red. Union, first one is green, second one is green, and third one is red. This is because this event can happen if the previous two draws are either red red, red green, green red and green green. Therefore, probability of third ball drawn is red is equal to summation of these individual probabilities. So, let me write them as follows: probability of R1, R2, R3 plus probability of R1, G2, R3 plus probability of G1, R2, R3 plus probability of G1, G2, R3. So, let us again go by the tree diagram. As I said earlier, that they are very useful when you are modeling the probability of a sequence of events. So, if it is R1, we go to 11, 8. If the second one is R2, then we go to 10, 8, and now we are looking for R3, and the configuration is going to be 9, 8. If the first one is G1, then we come to 12, 7. If the second one is red, then we come to 11, 7, and if the third one is red, then we come to 10, 7. Now, after the first one is red, if the second one is green, then we come to 11, 7, and if the third one is red again, then we come to the configuration 10, 7. Similarly, if the first one is green and second one is also green, then we come to 12, 6, and if then third one is red, then we come to 11, 6, and we need to compute the probabilities of this sequence of events, and then we have to add them up. So, let us calculate therefore probability of R3. The third ball is red. So, this is the product of 3 by 5 into R2, therefore, 11 upon 19 multiplied by R3, that is 10 upon 18, plus 3 by 5 into, now we are drawing a green, therefore, that is 8 upon 19 into, now we are drawing a red, that is 11 upon 18, plus 2 by 5 into, this is R2, therefore, 12 upon 19 into R3, therefore, 11 upon 18, plus 2 by 5, this is G2, therefore, this is going to be drawing a green, therefore, that is 7 upon 19 multiplied by drawing a red out of 12 and 6. So, that is 12 upon 18 is equal to 1 upon 5 into 19 into 18 multiplied by 3 into 11, 33 into 10, 300 30 plus 3 into 8, 24 into 11, that is 264, plus 12 into 2, 24 into 11, that is 264, plus 7 into 12 is 84 into 2, 168, is equal to 6, 2, 1026 upon 5 into 19 into 18 is equal to, let us cancel now, 18 cancels with 1026. So, what we have, 5 into 18, 90, so 126, 7 into 18 is equal to 126, is equal to 3 upon 5. Therefore, we see that the unconditional probability that the third ball drawn is red is same as the initial probability that the first ball drawn is red. So, this is a very interesting observation, and this is true not only for third draw. If we proceed, then we can see that same unconditional probability will remain for all successive drawings as well. Okay friends, let us now start a new problem. Suppose you have 3 fair dice such that probability of 1 is equal to probability of 2 is equal to probability of 3 is equal to probability of 6 is equal to 1 upon 6 for all the 3 dice. Also, you have a fake dice which has 4 faces as 5 and 2 faces as 6. You choose one of the 4 dice at random and throw it. You get a 5. Question is, what is the probability of getting a 5? And second question is, given that you have got a 5, what is the probability that you have chosen the fake die? So, I hope you understood the 2 questions. So, let us solve them. First is A. So, you are getting a 5, you are starting from here, you can choose a fair die, that probability is 3 by 4, and then you are throwing a die and getting 5, that probability is 1 by 6. You have chosen the fake die, that probability is 1 by 4, and then you are getting a 5, that probability is, because there are 4 faces 5 and 2 faces 6, so that probability is 2 by 3. Therefore, probability of 5 is equal to probability of 5 given fair die into probability of a fair die or choosing a fair die plus probability of 5 given a fake die and probability of choosing the fake die is equal to 1 by 6 multiplied by 3 by 4, because there are 3 fair die and 1 fake die, plus 2 by 3 multiplied by 1 by 4 is equal to 3 upon 24 plus 4 upon 24 is equal to 7 upon 24. So, that is the answer. The second question is that what is the probability that you have chosen the fake die given that your result is 5. This question, if we analyze, we see that it is somewhat different. In the earlier question, we were starting from this point, and as we are moving with the trial, we are trying to figure out what is the probability of a particular event. In our case, the event is getting a 5 on the throw. But this question is saying something different. It is saying that this output is 5, and based on that we are trying to figure out what is the probability of this event, that you have chosen a fake die. So, this probability is called a posteriori probability, that is after the result we are looking at the probability of the initial event. As you know that this can be solved using Bayes theorem. So, what it is? We know that probability of A given B is equal to probability of A intersected with B divided by probability of B. Now, this we can write as probability of B given A multiplied by probability of A divided by probability of B. So, our problem is probability of fake die given that we got 5, therefore, we can write it as probability of 5 and fake die divided by probability of 5 is equal to probability of 5 given fake die multiplied by probability of fake die divided by probability of 5 is equal to probability of 5 given a fake die is 2 by 3 probability of getting a fake die is 1 by 4, and overall probability of 5 is 7 upon 24 is equal to 2 by 12 multiplied by 24 by 7 is equal to 4 by 7. That is the answer. Now, you have to remember that we got probability of 5 by considering all the disjoint events that result in 5, and then we have added over that the same way we have done in the previous problem. Let us now consider another problem. Suppose you have 10 coins numbered 1, 2, 3 up to 10. Suppose probability of getting a head in single toss of the ith coin is I upon 10, I is equal to 1, 2 up to 10. You choose a coin randomly and toss it. If the result you got is a head, what is the probability that you have chosen the fifth coin? So, that is the question. So, we can solve it in this way. Let E be the event that you choose the fifth coin and B be the event that you got a head we want to compute probability of E given B. Therefore, using Bayes' theorem, probability of E given B is equal to probability of B intersected with E divided by probability of B is equal to probability of B given E multiplied by probability of E divided by probability of B. Now, probability of B given E that is probability of a head given that you have chosen the fifth coin is equal to 5 by 10 is equal to half, and probability of E is equal to 1 by 10 as the coin is chosen randomly. Therefore, probability of E given B is equal to half multiplied by 1 by 10 divided by probability of B, that is probability of getting a head. Now, probability of B is equal to probability first coin is chosen and you got a head plus probability second coin is chosen and you got a head up to probability 10th coin is chosen and you got a head is equal to probability of head given first coin into probability of first coin plus probability of head given 10th coin into probability of selection of 10th coin is equal to 1 by 10 into 1 by 10 plus 2 by 10 into 1 by 10 plus up to 10 by 10 into 1 by 10. This is because the probability of head for the ith coin is I by 10 is equal to 1 by 100 into 1 plus 2 plus up to 10 is equal to 1 by 100 into 10 into 11 by 2 is equal to 11 upon 20. Therefore, probability of E given B is equal to, from here we get 1 upon 20 divided by 11 upon 20 is equal to 1 upon 11. So, that is the answer that we get by applying Bayes' theorem. Let us solve another problem. Suppose a student is answering an MCQ question with 5 options, of which only one is correct. Now, let P be the probability that the student guesses the answer, that is, he ticks randomly, and let 1 minus p be the probability that he knows the answer and therefore ticks correctly. Suppose the student ticked correctly. What is the probability that he guessed the answer? That is the question. Solution: we want to find out probability of guessing given ticked rightly. Let E be the event that he guessed it and B be the event that he ticked it correctly. Therefore, we want to compute probability of E given B, which is same as probability of B given E into probability of E multiplied by probability of B. Now, probability of B given E, because he is randomly ticking and there are 5 options, that the probability he has ticked it correctly is 1 by 5, and probability of E that he is guessing the answer is P, that is given, and probability of B is equal to probability of B given he is guessing multiplied by probability of guessing plus probability of B given he knows the answer multiplied by probability he knows the answer is equal to 1 by 5 multiplied by P plus 1 multiplied by 1 minus P is equal to P plus 5 into 1 minus P upon 5 is equal to 5 minus 4P upon 5. Therefore, probability of E given B is equal to P by 5, P into 1 by 5 divided by 5 minus 4P upon 5 is equal to P upon 5 minus 4P. That is the answer. Let us solve another problem. Suppose you have 3 bags A, B and C. The contents of the bags bag A has 1 white ball, 2 green balls and 3 red balls. Bag B has 2 white balls, 1 green ball and 1 red ball. Bag C has 4 white ball plus 5 green balls plus 3 red balls. You choose a bag at random and take out 2 balls from it. Suppose you get 1 white and 1 red ball. What is the probability that you have chosen bag A? Again you understand that we are again computing the a posteriori probability of the bag A, given that you have chosen 1 white and 1 red. So, solution: let E be the event of selecting bag A and B be the event of getting 1 white and 1 red ball. We want to compute probability of E given B. Therefore, using Bayes' theorem, probability of E given B is equal to probability of B given E multiplied by probability of E divided by probability of B. Now, probability of E is equal to 1 by 3 and probability of B given E, that is selecting 1 red and 1 white ball out of the bag A, is equal to 3 upon 6 C2 is equal to 3 upon factorial 6 factorial 2 factorial 4 is equal to 3 upon 5 into 6 by 2 is equal to 1 upon 5. Similarly, probability of 1 white and 1 red ball given bag B is chosen is equal to, now bag B has 4 balls, out of which we can choose one white and one red in 2 different ways, and 2 balls can be chosen in 4C2. Therefore, the answer is 2 upon factorial 4 factorial 2 factorial 2 is equal to 2 upon 6 is equal to 1 upon 3. And probability of 1 white plus 1 red given bag C is equal to 12 upon 12 C2 is equal to 12 upon 11 into 12 by 2 is equal to 2 upon 11. Therefore, probability of B is equal to probability of 1 white plus 1 red is equal to 1 by 5 into 1 by 3, that is for the bag A, plus probability 1 by 3 into 1 by 3, that is for bag B, plus 1 by 3 into 2 by 11 is equal to 1 by 3 into 1 by 5 plus 1 by 3 plus 2 by 11 is equal to 1 by 3 into 165, 33 plus 55 plus 30 is equal to 1 by 3 into 118 upon 165. Therefore, probability of bag A given 1 red and 1 white is equal to 1 by 5 into 1 by 3 upon 1 by 3 into 118 upon 165 is equal to 1 by 5 into 165 divided by 118 is equal to 33 upon 118. That is the answer. In a similar way, you can calculate for other 3 bags and you will find the answer accordingly. In fact, you can see from here and you can understand that the a posteriori probability for bag B is going to be 55 upon 118 and for bag C is going to be 30 upon 118. Let me solve one more problem on conditional probability and Bayes theorem before we stop. Suppose you are waiting for a letter from Kolkata Kathmandu and Muscat. Suppose you receive a letter and the only thing legible in the address is two successive letters AT. Now, AT is there in Kolkata, it is there in Kathmandu, it is there in Muscat as well. What is the probability that it is from Kolkata? That is the question. Therefore, what we want to know is probability of Kolkata given AT successively is equal to probability of two successive letters are AT given Kolkata into probability of Kolkata divided by probability of AT as the two successive letters. Now, probability of AT given Kolkata is equal to, there are 1, 2, 3, 4, 5 and 6. There are 6 possible pairs of successive letters. Therefore, this probability is 1 by 6. Probability of AT given Kathmandu, there are 8 possible pair of letters. Therefore, that is going to be 1 by 8, and probability of AT given Muscat is equal to 1 by 5. Therefore, probability of Kolkata given AT is equal to probability of AT given Kolkata, which is 1 by 6 multiplied by probability of Kolkata, which is 1 by 3, divided by, as you can well understand, 1 by 6 into 1 by 3 plus 1 by 8 into 1 by 3 plus 1 by 5 into 1 by 3 is equal to 1 by 6 upon 1 by 6 plus 1 by 8 plus 1 by 5 is equal to 1 by 6 upon 5 into 6 into 8, 40 plus 30 plus 48 is equal to 40 upon 40 plus 30 plus 48 is equal to 40 upon 118, which can be further simplified, is equal to 20 upon 59. That is the answer. So, let me finish the session with a tricky problem. Suppose India and Australia are playing a 5-match test series. Suppose Virat Kohli won the toss in the first 4 matches, what is the probability that he will win the toss in the 5th match as well? So, that is the question, and let us put it in an MCQ mode. Option A is 1, option B is 1 by 5, option C is 0, and option D is half. Let us assume that the toss is done using an unbiased coin, so that in each toss the probability of winning is equal for both the captains. Because since Virat won all the previous tosses, therefore, he will win the fifth toss. But that is not correct. This will be a wrong answer. Can it be 1 by 5? Why? Because Virat won all the 4 tosses, therefore, now the Australia captain will have 4 by 5 probability of winning, but this is also not correct. Therefore, we strike out that option. Can it be 0? Because now Australia captain will have to win the toss. Therefore, probability Virat winning is equal to 0. That is also a wrong answer. Therefore, we cancel that. Therefore, the correct option is D, that is answer is half, because probability Virat winning fifth toss given he won all the previous tosses is same as probability Virat winning the toss, as these are independent events. Therefore, correct answer is half. Therefore, the student should take D. Okay, friends, I stop here today. In this class, we have solved quite a few problems involving conditional probability and Bayes theorem. In the next class, I shall work on binomial distribution and also show the utility of binomial theorem in computing the number of certain combinations to happen. Okay, friends, thank you so much.